Welcome to All About Analytics. In previous tutorial, we have learned that how can we clean the data using different techniques. So in previous tutorial, we have seen how can we ignore the missing values and clean the data sets. So let's move on to our next tutorial, which is on handling missing values manually and measure of central tendency. So the second method is fill missing values manually. So in this case, what we do is we remove NaN values with any constant value. For example, I wanted to put 0 instead of NaN. So I will fill 0 in all rows where NaN is present, right? And the third method is measure of central tendency. So in measure of central tendency, what we do is, for example, you see a price column there and it is having a missing value. So what we will do is we will take the mean of price column, whole column, right, and replace those NaN values with the mean of the same column. This is called measure of central tendency. And instead of mean, we can also use median values. So let's start for practical implementation for filling missing values, right? So first, or import all these libraries, import pandas, spd, matplotlib, and cbond, and this is my datasets path. So now I'm converting this dataset path into a data frame, right? So let's start it pd dot data pd dot read underscore csv, because this is a csv file, you know. Pth path. I'm storing this path into a data variable. So now let's see the first 5 rows of data dot head. It will take some time until this black dot comes wide, so our code will get executed. So we have to wait for some time. So as you can see, we have got first 5 rows of our data set. So our data set has 80 columns and 5 rows it is showing because I have applied head function. So it is, as you can see, it is not showing full columns. It is showing only some first 5 columns and last 5 columns. So what we have to do is we have to apply the function which I have told you in the previous tutorial, pd dot set underscore option, and inside this function we have to pass argument display dot max underscore columns, 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 comma none. None is, I'm using none because I wanted to print all the columns, right? So if you wanted to print first 10 columns or first 20 columns, so you can write 10 or 20 instead of none. Okay, so I'm also applying this function on rows, pd dot set underscore option display dot max underscore rows, comma none. And always remember, keep this n as capital, then it will only show your data frame completely, right? So as you can see, I've executed it. Now let's save our data frame, data dot head. So as you can see, it is showing all those columns right now. See, we are getting all 81 columns right now. Okay, so now let's check the shape of the data dot shape argument, data dot shape. So we have 80 columns, sorry, I was saying 81. We have 80 columns and 1459 rows, right? So now let's select out how much percentage of data is missing from each data column, right? So for doing that, we have to do is data dot is null function. This null function tells you where data is missing. Dot sum, it will sum the data from each column, from each column how much number of data is missing, right? That's why I'm using dot sum function. Into no sorry, dot mean. We wanted to find out the percentage na, into 100. This code will give you the exact percentage from each column, that how much data is missing from each column. So data, so I'm giving this percentage to miss underscore percentage. So let's execute this miss underscore per run. Sorry, we have to do it like this. We have to remove for sum. If you wanted to check all those values, that how much values are missing from the column, but if you wanted to take out the percentage, then we have to do it like this: data dot is null dot mean into 100. Now it will show all the columns, that from how much percentage of data is missing from each column. So as you can see, from lot frontage we have 15% data missing, from alley we have 92% data missing, from mass phenotype we have 1, right, from BSMT call column, and these are some columns from where data is missing. Here from this column fireplace we have 50% of data missing, right. Here you can see pool QC fans and miscellaneous features, we have 90, almost 90 to 80% data is missing. So what we will do is we will find out all those data which all those data columns names which are having greater than 20% data missing, right. So we will delete those columns. So I'm giving variable name drop call and finding out data dot, I'm using this miss underscore per, this data frame miss underscore per, inside this miss underscore per greater than 20% of data is missing dot keys. This will give me the columns names of those columns which are having greater than 20% data missing. Drop underscore call. So these are some columns which are having data missing more than 20%. Now what I will do is I will drop these columns from the data set. So let's stop this data dot drop. Now pass the arguments columns function columns columns equal to, and give the column name drop underscore call, because this column contains a list in which we have these columns names which we have to delete, right. Now save this into a new data variable. I'm giving its name as data1, right. So all these all these columns are dropped. So now if we check the shape of the data1 dot shape, so we will see some reduction in column. See, as you can see here, we are having now 75 columns. Okay, so now what we have to do is, now we will impute numerical variables first. So let's select numerical columns first, right. So we will impute the mean or median values inside the numerical columns first. So first we have to find out what are our some numerical columns. For selecting the numerical columns from the data set, so we will do it like this: data1 dot select underscore d types, right, include, this is the argument in which we have to include which kind of data we want. We wanted to include this inside this data frame, right. So I want int 64 comma float 64, float 64. Let's assign this to a variable name, and I'm giving that variable name is numerical underscore variable, right? So now we will, if we print this num underscore var, so this will give us all those column names which are having numerical variables. So as you can see, now we have got all those columns which are having only numerical variables. Not had. See, as you can see, we are having almost all those numerical columns right now in this data set, right? So now we will check that how many numerical variables have missing data inside them is null dot sum. So lot frontage is having 227 missing values. Mass Vienna area is having 15 missing values, right? Garbage air BLT is having missing values. Garbage area is having missing values, right? So now we have to extract all these columns which are having missing values inside them. So let's extract these columns. So first of all, I will create a for loop for var in num underscore var dot columns columns, right? Now I will apply a if condition. If numerical underscore variable var having missing values greater than 0 dot is null dot sum greater than 0, then return me the variable's name, right? So this will return us a variable name var, and I'm saving the list of these columns inside a variable called miss underscore num underscore var. Now let's print this. Now let's print this miss underscore num underscore var. So as you can see, these are the columns, numerical columns, which are having missing values inside them. So now let's impute them. So what values we are going to impute inside these NaN values, mean or median, right? So but how we will get to know that in which column we have to replace NaN values with mean or median? So for doing that, we must have to check the data distribution of each columns, right? So so if the data distribution forms a mountain form, means you can also say it as if it shows a normal distribution or a Gaussian distribution, right? So then we have to impute mean value in that column, right? And if it is showing some skewed distribution table, a skewed graph, right? So in that case we have to impute median values in that column. So I'm showing you how we can plot the distribution plot, right, for each column. SNS dot test plot data 1 not frontage column. Wait, let's impute the missing values first, then we will plot all those distribution plots, right? Let's first impute all those missing values first. So for filling the missing values, what we have to do is we have to use fill_na function. Num underscore, so what, num underscore var dot fill_na miss underscore num underscore var. Dot mean. What we are doing is we are getting all these columns and taking their mean and filling this into a numerical variable, right? And now I'm saving this into a numerical underscore mean. This is a list object, right? Wait a minute. Underscore underscore mean. So now we have imputed the missing values. So let's check that our missing numerical columns have any missing values or not. Num underscore mean dot is null dot sum. So as you can see now, no any column has missing values inside them, right? So now let's plot a distribution plot for them, that how our data was looking previously before the missing value imputation and how it is looking after imputation, right? So we will do it like this. What we have to do is we have to create a figure size first, plt.figure. Now create a fixed size inside it. Fixed size equal to create a tuple inside them and give the size 10, 10. Sorry, like this. Now sns.set. This is not important right now. Now use a for loop for I, comma, var and enumerate read missing. I want all those column names in which we are having missing value greater than 0, right? So here is the name. And put them inside this bracket. So what enumerate function is doing is it is giving us rows from it is giving us rows of each column from 0 to until the data set finished, right? From each column it is giving the index of the first rows number or column number, right? In this way. Now let's let's create a subplot inside it. Plt dot subplot to how many feature variables we are having right now. We are having almost 1 2 3 4 5 6 7 8 9 10 11. So we will get 5 comma 6 comma I plus 1. Now let's plot the distribution plot. SNF dot dist plot. Now what I'm doing is I'm plotting the first one, num underscore var, which is this graph is imputed already. I have replaced all those missing values from this graph. Right? This is the imputed graph where numerical underscore var comma bins equal to 20 comma kde underscore kws. KDE stands for kernel density estimator. If you have known about Seaborn library, so they have detailed they have detailed introduction of KDE. What is it? You can check it on Seaborn's website. Okay, so what I'm doing inside this is, inside KDE I'm giving colors and line width of the graph. Line width. I'm creating a dictionary. Inside dictionary I'm inserting a key, line width is 8 comma color color and color I wanted to give is red, and this way our first plot will come out. Now I want the old graph also before imputation, how our data was looking. So we will do it like this. Dist plot sns dot dist plot num underscore var not num underscore var, we will use data underscore variable comma bins equal to 20 size comma kde underscore kws equal to line width. I'm giving 8. So I don't want to give line width 8. I wanted to give it 3. It will be too large for this size. Comma color is green. Right. And here what we have to do is we have to change this in numerical underscore mean. Now we will plot a correct graph. Let's run it. So as you can see, we are getting all those graphs. In this we have imputed in we are right now we are right now we have imputed all those mean values inside each column. So as you can see the difference, this the green one is showing original before imputation and the red one is showing after imputation. So this is the difference between them, right? In this case, here it is, here in garage pylt, this in this column we didn't got any much difference yet, right? In this column we didn't got any much difference in this one and this one and this one. So in some of these columns we didn't have got any changes inside our data set, because very less we didn't got any changes because there is very less amount of values are missing. Like, and there must be values missing like 1 2 8 10. That's why didn't we didn't get any change inside it. Okay, so we can also set a label instead of for again recognizing that which color belongs to which dataset. Plt.legend is a function, not legend. Comma label equal to, this is or imputed value, and this is label equal to, this is original value. Now run this code. Changing this from 2,5. Let's see what some changes we are getting. No, we are not getting. This was the same. Actually, I wanted to plot, give it a used to a num must be 1. Shit. 5, 6, 11 plots we will get. And here I'm changing this plot size to 20 so that we can get a big picture, but this didn't work. It works right now after changing this plot size. So here you can see imputed values are coming in blue color and original values are coming in orange color, right? So in this columns we can see here are some changes, right? So in red color are the mean values, right? As you can see, we have applied red values for mean, and green color to the old data set. So here we have changes because values which are missing is 259. So we have got some changes inside them. Here we didn't got any results much because the values which are missing here are in this column is just 8 values, and same in other columns also in these. Here we have seen some changes. Here the original is somewhere about here and the green almost somewhere 50 or 60 columns must be sorry, 50 or 60 rows are having missing values. That's why we have got this much changes here, and rest of them are having same kind of plots, right? So in this way we can check that how we can impute our data set. And I have used mean. You can use instead of mean, you can also apply median or median to those. Just what you have to do is just you have to mean and change mean instead of median, right? You can use me you can change here, and you have to write a median like this. Okay, now if you will execute the code, and then you will get the same results, like, because there is nothing much different between mean and median. Median and mode values are almost same. Sometimes, for example, if your mean is 40, then your median value will be less than 40. It could be 39 or it could be 42. So there is nothing much more difference between all of them, right? Well, you will get difference when the number of variables which are missing is more. Then you will get differences from these. Okay, and the other thing is how we will get to know that in which column we have to impute which kind of value. So as you can see here, we are getting a mountainous form or a normal distribution. See this, we are getting a mountainous form here like this, right? So this is called normal distribution or Gaussian distribution. In this figure what we are getting is skewed figure. This is skewed. It is asymmetric, not symmetric. This one is symmetric, but this is asymmetric. So in this kind of columns, mass VNR area, and this kind of columns, what we have to impute mean values, right? Sorry, median values. And which are symmetric columns, or which are showing Gaussian distribution type. Then in this kind of columns, we have to impute mean values, right? So did you understand the concept? If you are having any kind of problem, or so, you can write it on comments and I will surely work on that. So for categorical variables, you have to follow the same procedure. You have to first extract all those categorical variables which are having greater than 0 values, right? And you have to select for categorical variables. You have to use what you have to use is you have to replace int instead of int or float. You have to write object, because categorical variables have the data type called data type is object, right? Then what you have to do is you have to extract all those values, all those columns names which are having greater than 0. Then you have to apply mode value for categorical variable. Always remember, when in case of categorical variables, we always apply mode values. Not, we don't use mean or median values. Mean and median values are always used in numerical variables, but in case of categorical variables we always use mode values. Okay, so this was a tutorial about measure of central tendency and how to fill missing values inside your data frame. So thank you so much for watching, and let's meet you on the next tutorial. Thank you.